I was asked to speak specifically on dihydrotestosterone. So before I go into my lecture, let me briefly disclose my interests. As you will see, I've been engaged with many players in the industry in the last years. Let me also mention that I've been an investigator in the Lotus trial program on dihydrotestosterone, but I've also been an investigator on the subcutaneous progesterone, which is now on the market, and I've also been working with virtually all the companies that produce progesterone in the context to be used in the context of ART. So I was asked to touch three aspects. Number one is the compound. So we talk about dihydrotestosterone, and here you see progesterone and dihydrotestosterone. You see the structural formula. You also see that dihydrotestosterone is a stereoisomer of progesterone. And so what you see here is there's a difference in hydrogen bonds, and there's also a difference in conformation of the molecule. And it is believed that this distinct stereoisomeric conformation and the hydrogen bonds make that molecule very resistant to metabolization, and also make that molecule to act very specifically with the progesterone receptor and not cross-react with other receptors. And I'm going to allude into that a bit further. So what we do know is that dihydrotestosterone has a much higher oral bioavailability as compared to progesterone. So it is estimated that dihydrotestosterone, the oral bioavailability is approximately 28%. That compares with approximately 4 to 8% for micronized vaginal progesterone capsules. And we all know that there's very poor oral bioavailability of oral progesterone. And accordingly, the doses that we use for dihydrotestosterone are much less as compared to vaginal progesterone gel or micronized vaginal progesterone capsules. But where does that really come from? And I think it's quite interesting to look back. This is a publication from the mid-80s. From King et al. These were people working at Imperial College in London. These were pharmacologists and biochemistry people. And so what they did, they were giving oral gestogens to women that were estrogen primed, postmenopausal. They did different dosages, and they did endometrial sampling and looked at biochemistry and morphological features of these endometrial samples. And so we look on the left panel into relative potency of norethindrone versus methoxyprogesterone acetate, and you see there's approximately a difference by the factor of 10 between NET and MPA. And then it's only 2% potency left of dihydrotestosterone as compared to NET, and then it's only 0.002 of potency left for progesterone when given orally as compared to the synthetic gestogen NET. And now if you convert that back into the dosage that is used at that time for NET to induce transformation of the endometrium, you see this is 0.35 milligram now. And now the equipotent dose of MPA would be 5 milligram. This is also what is very familiar to all of us even today. It is 10 milligram of dihydrotestosterone, or is 200 milligram of progesterone. So mind you, this is oral administration. But so this is where all that comes from, these different doses by different potencies. Now, let me also emphasize that progesterone is quite an interesting molecule, because in the body it can be metabolized in all different pathways and directions. And what I have here is not even all the metabolites that are there that come from progesterone, some of them being inactive, some of them being methodically active, some being anti-methodically active, some cross-reacting at the mineral corticoid receptor, others cross-reacting on the androgen receptors. And interestingly, this is not the case, or to a much lesser degree, the case for dihydrotestosterone. And again, it is believed that has something to do with these enzymes in the human body being able to crack up these hydrogen bonds and this molecule as it is. And so for dihydrotestosterone, there's only 3 known metabolites, and this is the dihydrodihydrotestosterone with alpha dihydro at different positions within the alpha. I don't know the word for that in English, within the molecule. And it is also well known that dydrogesterone has gestogenic action and has no relevant clinical partial action on any of the other receptors. Bear in mind, though, that dydrogesterone, the vast majority of that is rapidly metabolized into 20-alpha dihydrogesterone. So everything that I just said has recently been summarized by Herbert Kuhl and Inka Vigras. There's also an English short version of that available. So this was about the compound. Now let's look at the efficacy of dydrogesterone. And I'm now focusing on assisted reproduction, IVF, luteal phase support, and early pregnancy support. So let me mention that dydrogesterone was tested after centuries of empirical use in many countries on a large scale. Eventually, dydrogesterone was tested in a large phase 3 trial program. Let me mention that this is the largest luteal phase support trial program that our field has ever seen, with two very prominent studies. It is the Lotus 1 study and the Lotus 2 study. And I think it's really worthwhile to look at these studies and familiarize yourself, because I do think they make an impact on how we look at luteal phase support. So let me also mention upfront, both studies are of high methodological quality, and let me emphasize for the case of the Lotus 1 trial that this was a double-blind, double-dummy, placebo-controlled, of course, multi-center randomized trial on 1,000 patients. The Lotus 2 trial was an open randomized controlled trial. I really like the Lotus 1 trial with the double-dummy placebo-controlled design. Why? Because bear in mind, I mean, it's double blind, so neither the woman nor the doctor knows what the patient is getting, and the patient also takes a placebo dummy medication. So every patient had a pill to swallow at the same time, put a capsule in their vagina. And I'm emphasizing this because I think that for tolerability aspects, or most importantly, maternal safety aspects, I think this is of crucial importance, because here no patient can cheat. So you will have some nocebo effect in the trial, but since the patient gets both routes of administration and is double blind, the patient cannot cheat on adverse events. And so we have that in 1,000 patients. That's quite remarkable. And I also have to say that I was quite skeptical when I started to work on the Lotus 1 trial that for maternal safety, we would not see a difference from a progestogenic, rather high dose administration, even into early pregnancy, where these women and the livers get under stress. But let's have a look at that later. So 1,000 patients each, huge trials, multicentric, multinational, as I said before. And what was done in these trials, so patients were screened and enrolled during ovarian stimulation, very lifelike environment, so any ovarian stimulation, and then oocyte retrieval, and then patient was randomized. And in Lotus 1 and 2, it was the same study drug scheme, which was 3 times daily, 10 milligram of oral dydrogesterone. And the comparator in Lotus 1 is micronized vaginal progesterone capsules, 3 times 200, or once daily micronized vaginal progesterone gel. And then you see the efficacy assessment here. So positive pregnancy test, clinical pregnancy, and the primary efficacy outcome was ongoing pregnancy at 12 weeks of gestation. Then these pregnant patients were followed throughout their pregnancy into live birth with a complete data retrieval on the neonates, and in a subgroup of the neonates, even after 6 months, another assessment for any adverse events in the fetuses and neonates. So what we have here now in Lotus 1 and 2 combined is approximately 2,000 patients, half of them in a double-blind, double-dummy placebo-controlled trial, the other in an open randomized controlled trial, that we have all the data from oocyte retrieval into childbirth. So that's quite an awesome database to look at. So if we look who were the women in these trials, and I cut the story short, it was a very regular, very wide phase 3 trial population, women undergoing IVF for ICSI, having single or double embryo transfer, and fresh cycles only, of course. And who was not in the trial, also cutting the story short, recurrent implantation failure, recurrent miscarriage. These patients were excluded. So this was not the target population. So let's look at the primary efficacy outcome in Lotus 1. So here we see ongoing pregnancy and live birth rate, and what you see here is the proportions for the two arms. And you see a difference in favor of oral dydrogesterone, which came a bit as a surprise to me. And the way we look at these data is in the context of a non-inferiority trial, that we look at the difference in outcome, which is, if we look back that slide, from here to here, and now you do an adjusted difference by center. So you have approximately a 4.7, 4.9, so roughly a 5% difference in ongoing pregnancy and live birth rate in Lotus 1 in favor of oral dydrogesterone. So 5% more ongoing pregnancies and live birth here. And in the context of a non-inferiority trial, what you do is you now look at this difference and you build the confidence interval around it. And now the confidence interval must exclude differences not in favor of oral dydrogesterone of a magnitude of -10. This is the non-inferiority margin. If you look closely at the lower bound limit of the confidence interval, you see this is very far away from the -10 margin. But what was really a surprise to me when I looked at these data first was, if you look at the upper limit of the confidence interval, what you see here is there's differences not in favor of micronized vaginal progesterone, the gold standard so far, of a magnitude even exceeding a 10%. So 10 point something, 10.6 here, 10.7 for ongoing live birth, 9%, 8%. So all these differences are included in that confidence interval. And that means really that after the Lotus 1 trial, non-inferiority of micronized vaginal progesterone capsules, 600 milligram against oral dydrogesterone, came under scrutiny. And this was to me a bit of a shock, because I came from a clinic where we're using 100% micronized vaginal progesterone, because this is how I grew up with, so to speak. And now suddenly I had data on my desk telling me, well, you can no longer be assured that this is not indeed worse. This is less women have an ongoing pregnancy and live birth. So this was Lotus 1. So we're extremely excited to see then the findings of Lotus 2. And here you see the ongoing pregnancy rate, live birth rate in Lotus 2. Mind you, again, this is oral dydrogesterone, this time against vaginal gel. A very similar picture, and maybe it's easier if we look at it graphically again. So here we have approximately a 3.7% difference for ongoing pregnancy rate in the Lotus 2, very similar and very much in line with Lotus 1. Here again, you see also Lotus 2 as a study per itself, firmly established non-inferiority of oral dydrogesterone. So this is what these studies were designed for. Now you will say, well, now you have these two trials, and these trials are super comparable because the study medication is always the same, oral dydrogesterone, all the assessments are the same. They are of very robust methodology. So what if you now combine the data? And of course, this is what we did. So we can look at study 1 plus B. This is what we call an aggregate data collation or meta-analysis. But here we had the beautiful situation that for each and every woman, we knew what trial was she in, we knew what medication did she receive, but we also knew the age of the woman, how many embryos she got transferred, what stage of embryo development, and all that. And so rather than looking at study findings, we could look at the outcome of individual women. So what we did was an individual participant data analysis. This has been published just last November, so pretty fresh. And what you see here is now the combined analysis for ongoing pregnancy and live birth rate. And again, this came quite as a surprise to me as an investigator in these trials, that we now see superiority. So we see oral dydrogesterone outperforming micronized vaginal progesterone capsules and progesterone gel when it comes to ongoing pregnancy achievement and live birth achievement by the factor odds ratio of 1.32, 1.28 for live birth. And in absolute numbers, that means if you run a center and say you treat 1,000 women a year, which are similar to the women that were treated in Lotus 1 and 2 trial, and you have a similar pregnancy rate as was observed in these trials. That means if you put all these 1,000 women on oral dydrogesterone instead of vaginal progesterone, you have approximately 40, in absolute terms, 40 additional ongoing pregnancies. So we also talk about an effect size, which I believe most of us do consider relevant. Now, to put this further into perspective, what we observed in our meta-analysis is what are the other confounders for chance of success. And of course, it is age. Age has to pop up. So the higher the age of a woman, the less likely she is to conceive and have an ongoing pregnancy. But what is amazing is if you look at the day of embryo transfer. So we all know you have a blastocyst to be transferred. This is more positive than cleavage stage embryo in terms of prognosis. And so the odds ratio with the blastocyst transfer across these 2,000 women is 1.25 in favor of blastocyst transfer. But now compare this with the treatment arm. So what we observed in Lotus 1 and 2, that for the participants in that trial, it made more impact if they were put on oral dydrogesterone, not vaginal progesterone, as having a blastocyst instead of cleavage stage embryo in terms of effect size. I find this quite remarkable. Now you will argue, well, George, okay, this is only the Lotus trial program. That's 2,000 women. That's very robust data. But how about all the other data in the literature? And so what we did is we contacted all these authors from India, Iran, and so on that have run their own trials independent of any sponsor, etc., comparing oral dydrogesterone and micronized vaginal progesterone. We see quite some heterogeneity. We see some weaker methodology in there, but when we combine now all the other pre-existing evidence from other researchers with the Lotus trial program, this is what you see here, we see a statistically significant increase in the odds of achieving a pregnancy, and we see the same for live birth rate. Everything's fully published, all the data in PLOS ONE in November last year. So this is about efficacy. Now let's talk about maternal fetal safety. So as I said before, when I started on the Lotus 1 trial, I was really concerned that we give these women 30 milligram of an oral gestogen, not only in the luteal phase, but up to 10 weeks, 12 weeks of gestation. And we all know these women, the bodies get under stress, the livers get under stress. And I was sure we would see more adverse events, for example, cardiovascular system, thrombosis, and all that. And then let me emphasize again, in Lotus 1, we had a double-blind, placebo-controlled, double-dummy study design, so there's no cheating. And to my greatest surprise, we saw absolutely no difference in adverse events. So here what we have, the treatment emergent adverse event rate, at least one serious, at least one leading to discontinuation, is exactly the same. And then again, you will see this summarized for the two trials combined in the PLOS ONE publication. And then you will also argue, well, but then still as a gestogen, you can put your liver under stress. And so in Lotus 1, I'm re-emphasizing double-blind, double-dummy, placebo-controlled, 1,000 women. Changes in liver function test, the incidence of that with dydrogesterone, 2 in 1,000, micronized progesterone, 4 in 1,000. So not much of a difference. And certainly not any new safety concern for the liver with oral dydrogesterone. Now let's talk about the fetuses. Let me say that oral dydrogesterone has empirically been used and with an indication in pregnancy in numerous countries since more than 50 years. So we do know from pharmacovigilance that virtually millions of women have been exposed to oral dydrogesterone for the indication of threatened miscarriage, recurrent miscarriage, and all that across the globe since half a century. And pharmacovigilance so far has been negative. But now what we have here for Lotus 1 and Lotus 2, as I said before, we have a complete picture of all the adverse events with a complete neonate assessment. Some of the neonates even assessed again after 6 months after birth. And to cut the story short, and again, you see all of that in the PLOS ONE publication, we saw no difference. And if we look specifically at the congenital heart disease incidence with oral dydrogesterone, we had 443. Fetuses with micronized vaginal, we had 373. You see the difference here. And it's 1.8% for oral dydro versus 2.9. So no new safety concern with oral dydrogesterone from the largest luteal phase support trial program ever in the field of IVF. Nevertheless, there is some data in the literature insinuating, well, there could be an issue with oral dydrogesterone in terms of fetal safety. Now let me quickly elaborate on that a little bit. So in 2019, a paper came out by a colleague called Gideon Coren, and the title is Fetal Safety of Dydrogesterone Exposure in the First Trimester of Pregnancy. And that paper claimed that there's a fetal risk, specifically fetal heart defect risk, by the use of oral dydrogesterone. Now, me and a number of other colleagues looked at that paper, looked at these data, and we outrightly found the whole paper extremely awkward. Now, everyone who knows how difficult it is to retract a paper can understand what process started now that eventually lead to complete retraction. Because bear in mind, the editor-in-chief and his editorial colleagues and then peer reviewers, they assessed the paper. They said, we think it's good, so we want it published. And now you write a letter, and not only me, but many people write letters and say, well, these data must be outrageously wrong. They just don't fit next to each other within from table to table and all that. So eventually, after a month of going back and forth and hearing Coran and his team, that paper was completely retracted. There's no chance for erratum corrigendum, completely retraction of that. And then what you will also notice that I was trying to get the full list of retracted paper by Mr. Gideon Coran from retractiondatabase.org. It doesn't fit the screen, so it's very, very small. So that paper is within a long track record of fraud of Mr. Gideon Coran. Now, the problem is, well, you can do your own research if you wish. Mr. Coran has been licensed in Canada. He lost his license. Toronto Star has been chasing him. You will see, you can go on to YouTube, you find features on him. He had a lab called Mother Risk. Please remember the name Mother Risk Lab for a moment. There is For Better Science, the blog. You can read up a lot about Coran. Here it's called Coran a Toxic Waste. I never believe a colleague can be a waste. I assume this is the research and the publications that this blog is alluding to. This is from the Toronto Star that have put some investigators on some of his data and publications. So now the problem is, once fraud data are out there, they continue to pollute the literature. And I'll show you now how that works. So I was just telling you there's this retracted article. And now Mr. Coran writes a review article for prenatal cardiology. He submits that at a time while the other paper is still under investigation for fraud. So the publishers do not know. So eventually it is reference number 25 in a now published paper alludes to a database which was identified as fraud, but which is now a reference in an existing review article. Now, then other researchers or people in the field, like here it is Dr. Paul Piet, I believe, writes now the next review article. And now he's referencing the review article from prenatal cardiology, which then again has as a reference a database which been completely retracted because of fraud. Now, more of that. Gideon Coran writes the next review article. Now he can no longer reference a publication which is out there as retracted. No publisher would allow him to do that. So now suddenly, as a reference, you will see this here on the left, reference number 44, now alludes to another publication. And if you look that up, you see, wow, that's an abstract. But that abstract is the abstract on the paper that has been retracted. And so that thing continues to linger around and it goes in circles. And this is really, I mean, this is, I think it's an issue for all of us because such a thing can create a lot of anxiety. And I believe that it is the duty of all of us in the field to soberly look at what's been going on here and then see how much of that is worth to regurgitate and continue to use for whatever purposes in that context. Now, another paper frequently cited, and I'm coming quick to the end because time is running, but I think it's worth to discuss this, is a paper by Mahmoud Sakut. And this paper I see again and again, also insinuating a risk of cardiac heart defects in fetuses of the oral dydrogesterone exposure. And it is published in the Lancet, and you say, wow, that's the Lancet. I mean, the Lancet will only allow high-end studies in their journal. But then when you look closer, you will see, no, well, this has been published in pediatric cardiology. But then the Lancet picked it up without peer review and took it in a special issue, which was a political thing. And it's about research in the occupied Palestinian territory. This was a distinct Lancet initiative to sort of group these people together and see what type of research they were doing and then bring out a special issue. So when we approach the Lancet and say, well, this paper has major errors and flaws, the Lancet say we will not allow a letter because this is never been peer reviewed by us. And we just took the publication as it is and put it in a special issue. But the paper has major issues. And because time is running, it's very, very short. So there's 200 fetuses in there. And the notion is that after oral dydrogesterone usage by the mothers, these fetuses had more congenital heart defects. But to cut the story very short, let me just say that study is certainly a nice study by a small team working on a difficult environment for sure. But there's a violation of basic principles of epidemiological research. Number one is the study base is violated. So a woman does get dydrogesterone because there's a reason for that. And you cannot compare women with a reason for getting dydrogesterone with women without a reason for getting dydrogesterone. There's a lack of deconfounding. And this is women get dydrogesterone typically in pregnancy because they have had a miscarriage or there's a threatened miscarriage. And there's very good data in the literature, meta-analysis even, observational data showing that miscarriage risk or previous miscarriages is a strong risk factor for congenital heart defect. There's an issue with comparable accuracy. So it's recall of these women. And then there's a number of other issues in that paper. So I think it's an interesting paper, but it certainly does not qualify as data to insinuate that there is indeed an increased risk of congenital heart defects with oral dydrogesterone on 200 neonates. So now with time running, I would love to continue on that, but I had only time to talk about efficacy, safety fetal, safety maternal. We were talking about the compound, what we know. I did not have time to talk about tolerability, oral versus vaginal. I did not talk about patient preference. I think that's a no-brainer, really. I did not talk about patient preference. So what do you prefer? Clean vagina when you do a scan, your embryotransfer and all that. I did not talk about cost effectiveness, but bear in mind, it's not the absolute cost of a drug, but it is the cost per effect that we must look at in different settings. In Germany, it's pretty easy. It's an off-label use and it's extremely cheap. So in the cost effectiveness plane, I get more effect for less money. So again, it's a no-brainer on that occasion. So key literature, this is free for download, open access. Everything that I said today really is already there in a publication together with Christoph Blockhiel and Hermann Tourné from Brussels, which was Fertility and Sterility in 2018. So all the elaborations, and this was only after Lotus 1 already. I think the picture has been pretty clear that the Lotus 1 trial will induce a paradigm change in luteal phase support in IVF. And the other one is the recent publication PLOS 1, where we have both Lotus 1 and Lotus 2 systematically combined.